Today our topic is about the common base transistor as a voltage amplifier. And for common base transistor, we know that for this will be a meter, this will be base, and this will be a collector. Okay, this is a meter. Okay. If the arrow away from the base, if the arrow is away from the base, then that will be firstly I consider that if arrow is toward the base, then that will be defined as that will be a NPN and PNP transistor. If arrow is away from the base, then that transistor will be NPN transistor. Okay, so for active mode, there will be two junctions. Okay, so this there will be this junction will be a JEB, and this junction will be a junction C BC or a CB. Okay, as we know that this will be a input part, and this will be a output part of common base transistor. Okay, for common base transistor, we know that there is a for input. We know that the junction in active mode, for active mode, firstly we know that for active mode, the junction JEB will be forward bias, and junction BC, that will be a reverse. That will be a reverse bias. Okay. So if I draw the input characteristic of the because that will be a junction for input, that will be so this implies that for input, the input characteristic of this transistor will be like uh, the for because it is a forward bias. Like this, and the input voltage, as I have already explained, the input voltage V in will be equal to, yes, that will be a EB or EB for or BE. And EB, because E will be high for PNP, so that will be for PNP transistor, and this will be for NPN transistor, because in NPN the base will be high. Okay, so that will be, and input current will be IE, and similarly output for output or output. For output, if we draw the graph between for output, we know that the if IE is 0, input, this will be totally reverse bias IC. This will be a V out. V out will be, you may write V out, that will be uh, base will be high base collector for base collector or CP. For base collector, output voltage will be for base collector, it will be for PNP or and this will be for NPN. Okay, and but here the slope will be 0, but when the current is increasing IB, for example, if IE is 10 milliampere, IE is 20 milliampere. Okay, so the slope will be increase. Okay, and so this will be input characteristic, and that will be output characteristic, and I out will be, yes, I out will be collector current. But from these diagram or graph, we know that I is along the y-axis and V is along the uh, V is along the x-axis. As we know that the slope is always as we know that firstly we know as we know that V equal to V equal to IR, where Y in IV diagram V is along the x-axis and I is along the y-axis. In IV diagram, current voltage diagram, I mean a current, V mean a voltage diagram. In IV diagram of transistor. And the same is true for the diodes too. Okay. So so as we know that the slope always equal to, as we know that the slope is always equal to delta y over delta x. So if we consider, we consider that y is along the so I over v, from here mm, r will be equal to v over I. Okay, so because this is so from here this will be, slope will be equal to 1 over r. Okay, so because I is along the y-axis and v is along the, so this is a 1 over r, because r resistance, because uh, resistance says v over r. So this implies that So this implies that uh, slope is equal to I over R, 1 over R. Okay. So what is the meaning of this? This meaning is f- in the input characteristic. So this implies that the input input resistance, which is R in, yes, that will be equal to that in for input characteristic, input resistance, since the slope is very high, since slope for input characteristic is very high, mean uh, is very high, not small, is very high, is very high, very high. This implies that one slope input, which is 1 over R in is very high, implies that R in is very small. So as R in is very small, so voltage V, input voltage, this implies that input voltage will be a very small. And you may say that V in, V in, I in R in, where I in is IE and R in, because R is small, that will be a very small, because because of because R in is very small. But in case of output resistance, but in the case of output resistance, or you may say that load resistance, or the load resistance, yes, for load resistance, slope for IE is approximately 0. For IE approximately equal for IE is equal to 0, is nearly equal to 0, or out will be nearly equal to infinity, nearly to infinity. But as you may see that for this, okay, the here slope is nearly equal to 0. Okay, but here there is a, as we know, as we can easily observe, there is a little bit slope that is not equal to 0. This is like a 0, but this slope is not equal to 0, but it is a very high. But uh, so uh, uh, so uh, so slope for output when IE is not equal to 0, that will be also not equal for or I not equal to 0. Slope will not equal to 0, but slope, which is 1 over R out, is very, very, very small. You may say that that is not 0, but very, very small. This implies that R out, which is RL, yes, that will be a very, very, very large. So when that will be a very large, then V out, then V out, yes, that will be equal to I out over R out, while I out is equal to as we know that that is IC, and R out is PC or CB, BC for NPN or uh, PNP, and CB is for NPN. Okay, and that will be IIC. I think I must I out will that is BC for PNP or CB. Lecture is high, and this will be our load resistance. Okay, and that will be our out will be a very, very because RL is a very, very large, so that will be a very, very large because RL is a very, very large. So that mean and this mean for this implies that for V in very, very small, we will get V out very, very large. 1 minute, please. Okay, let me clear one thing. Uh, So because RL VB will be here 1 minute. Okay, here is IC, as we know that E is equal to IC plus IB, and IC is equal to alpha IE plus ICPO. I have already explained in the previous lecture. So that will be alpha E plus ICBO or L, that is very, very high. And that alpha, if we ignore that alpha is near to 1, as we know that that is near to, then that is approximately is equal to IE plus ICBO. ICPO or L. Because why this is very large? Because alpha is near to 1, and its value is from 0.95 to 0.98. Not exactly 1, but near to 1. So when we add ICPO, then that will become a larger. So that mean our and RL is already very, very large. So this mean this mean uh, uh, this mean V out will be a very, very large. So so we conclude. What is the conclusion? So we conclude. So we So we conclude that V out, which is depending upon the V out. Uh, so we conclude V out will be very, very large, will be very, very large for V in small. It mean for low, this implies that for low or small input voltage signal, input voltage signal, uh, we will get very large output voltage signals. So this mean that will be increase the signals amplitude at output. Uh, Voltage gain. The next is what is the voltage gain? Mm, uh, Voltage gain. Voltage gain will be equal to that will be equal to V out divided by V in. So that will be approximately, you may say that uh, that will be I C R L, and that will be uh, I E over R in. Okay, and since RL may be, you may say that this will be approximately equal to I, that will be equal to IE over RL, and IE over R in. Why? Because uh, IC is equal to alpha IE plus alpha ICO, and this will be approximately equal to IE, because ICBO is very small, and and alpha is near to 1, or you may say that 9.5 to 0.9, 0.98. So due to this, this implies that we may cancel this IE is IE. Approximately, this will be equal to RL over R in, and that will be a very, because RL is a very, very high, so that will be a very, very high. And approximately it's and approximately is value is from the 50 to 300. That will be a not voltage, because that is there will be a known unit, because this is actually the 2 ratio, so no unit will be no unit, because gain is ratio, so it will no have a no. So the voltage will be amplified, but current gain, if I say if we are interested to measure the current Uh, so say current gain, which is I out over I, mm, which is I out over V in. I out is IC over IE, alpha IE over alpha IE, and approximately, okay, not exactly. So this will be cancelled. Approximately equal to, yes, this will be approximately equal to uh, alpha, which is less than 1, okay, but near to 0.952, 0.98. So gain, current gain will be a less, and but voltage gain will be a very high. Okay, so this will be amplify the uh, voltage. Okay, uh, so it means the common base emitters may be used as a to amplify the voltage. Okay, voltage signal. Okay, input voltage signal. Let's try to understand it with the help of the example. Okay, as a exercise, let's suppose there is a one exercise. If uh, Vi input voltage is given that if input voltage is 200 millivolt, and input resistance is 20 ohm. As we know that output load resistance must be a very high for this. Let's suppose that will be a 5 kilo, 5 kilo ohm. Then find the V out. What will be the V out? And also voltage, and also calculate the voltage gain. Voltage, voltage gain. We have to calculate these two things. Okay. One is this, and that is this. Okay, we have to find, and let me say that we have to calculate one, and okay. So how we will calculate solution? As we know that Vi V input is I in R in, which is IE over uh, R in. R in is given, that is IE. So this implies that IE will be equal to V in over R in. Uh, V in is given, V in is 200 milliampere, no, millivolt, and R is R in is 20. 2 is 2, so then this implies that I E will be input voltage, input current will be equal to, yes, that will be a 10 milli ampere. Okay, this will be a input current, and V out. So let's V out will be equal to I out, R out. I out is IC, okay, and R out is equal to RL. IC is not given. IC is approximately, I have already told that will be round about approximately equal to IE or L. Okay. So IE is given is that is uh, 10 milliampere and RL is 5 kilo ohm. So you may say that 10 raised to power minus 3, 5, 10 raised to power 3. Okay, so that will become 50. That will become 50 volt. So V out will be equal to 50 volt. So this is a one part. This will be a one part. Now we have to we have a V out is given 50 and V in is given while V in is 200 millivolt. That is given. Okay, that is given in question. Okay, B part is two part or B part. Okay, second part is voltage voltage gain, which is V out over V out over V in. V out is uh, 50 volt. V in is 200 millivolt. 200 millivolt. Uh, Zero may be cancelled with the zero and 5 1 by 4. So you may say that this is 1 by 4 10 raised to power minus 3 because this is there will be a known unit, so that will be a 1 over 4 10 raised to power 3. You may say that 1 by 4 is equal to 0.25 10 raised to power 3. You may say that that will be equal to or you may say that will be a 250. So voltage gain will be equal to this. This will be. So the voltage will be increased if V in is given to 200 millivolt, the output voltage will be 50 volts. Okay, that will be a very high, and voltage gain will be around about the 250. So this all about that we may use the common base emitter as a voltage uh, amplifier. Okay. So this is a common base emitter as may be used as a voltage voltage amplifier. Okay. So for today it is enough. Now I will discuss the use of the common base transistor as a NOT gate. Okay. Hopefully, if you have any question, please don't hesitate. Put the question in the comment box. Thank you very much. Allah.